Okay, so I'm just going to do the last problem on this assignment, IB Style Problems, Chapter 8, Learning Target Number 1, because the front page you should be able to do. It's really straightforward. Just make sure you're using the right formula. Notice the icons here. This one you can use a calculator. This one you cannot use a calculator. So you're going to use your own fabulous multiplication skills to try and do this one. Okay, so to the back. This one also says no calculator. So let's see if I can do this without a calculator. The following diagram shows a circle with center 0, or O rather, sorry, and radius R. The circle is divided into 3 equal sectors. Find the exact value of theta. So here's theta right here. So it's the central angle of this shaded in sector. So I know that the whole circle has been divided into 3 equal sectors. I know all the way around a circle is 360 degrees, but it says it wants it in radians, so forget 360. I know 360 is the same as 2 pi. 180 degrees is 1 pi, 360 is 2 pi. That has been divided into 3 equal pieces. That's it. I don't have a calculator. I can't do anything else. So that's my answer. Theta is equal to 2 pi over 3. That is the value of theta. The area of the shaded sector is 3 pi centimeters squared. So find the radius. Okay, so I know the area, and I know the formula for area using radians is theta r squared over 2. And by the way, when we have this on a quiz, you will be able to use the formula packet. So I want to point out where these are on the formula packet. We are doing circular functions, and so those are functions like the sun rising and setting, the tides coming in and out. It's things that come and go and come and go, okay? Around and around they go, okay? Just like a circle. So in this part of the formula packet, we have our length of an arc and area of a sector. They're sitting right here. Okay, so that's what we're going to use. Area equals 1/2 theta r squared. I like to write it, though, like this. Theta r squared divided by 2. But feel free to write it either way. All right, so now I'm going to fill in, what do I know? I know the area. So the area is 3 pi. I know theta. Theta is 2 pi over 3. I do not know the radius. That's what I'm trying to find. Radius squared, all divided by 2. Okay, so in this case, it might have made more sense to use the formula that had times by 1/2, because that looks pretty ugly. But I can solve this right away. I can get rid of divide by 2 by multiplying both sides by 2. So cross out my 2's, and I get 6 pi equals all of this, 2 pi over 3 times r squared. Okay, I'm trying to get the r by itself, so I've got this mess here. I see this divide by 3, so I'm going to multiply both sides by 3. So I get 18 pi. 3's reduced to 1, and I'm left with 2 pi times r squared. Okay, this one I'm going to get rid of both of these at the same time. I'm going to divide both sides now by 2 pi. The pi's cancel out. Pi divided by pi is 1. 18 divided by 2 is 9. And look how fabulous this is. The square root of 9 is 3. R is equal to 3. Okay, the radius of a circle is always positive because it's just a distance, and distance are always positive. So we only take the positive root here. We only take the positive answer. So R is equal to 3. So that's the answer to letter B. Okay, letter C, find the length of the chord AB. All right, so I notice AB is this line segment right here. I want to know how long that is. And I've got this angle right here. I'm going to turn this triangle upside down. I'm going to do this. I'm going to look at it like this. So I'm trying to find this length right here, and I know the radius. I know the radius is 3. So that means this side is 3 also. And I know this whole angle is, what did I say it was? 2 pi over 3. So this whole angle is 2 pi over 3. So another thing that I happen to know is I could change that to degrees. I could write it as degrees. In fact, I think that's going to help me with this. So remember how originally I said, oh, the circle is 360. I can divide that by 3, and that gives me 120. So I think when I'm looking at triangles, I find that the degrees is more useful for me than the radians. So the radians were really helpful for the area of the sector. And if I had wanted the arc length, radians would have been really good. But I feel more comfortable in degrees when I'm trying to deal with triangles. So I'm going to go ahead and change that theta to 120 degrees. Okay, so my picture is getting kind of complicated, so I'm going to put it down here. I'm going to copy that triangle down here. I know this is 3, this is 3, this whole thing is 120 degrees, and I'm trying to find this length. All right, this is not a right triangle, so how am I going to do this? I'm going to make it a right triangle. If I just drop down a height right here, notice I have 2 right triangles. So I've just cut this angle in half, so now this is 60 degrees, and this is 60 degrees. So that means this must be 30 degrees, and lo and behold, I have a 30, 60, 90 triangle. Oh my gosh, how convenient is that? So I've got 60 degrees, 30 degrees, and I know this is 3. So from my shortcut triangles that we were practicing in class this week, I know that this side, if I knew this side, I would double it to get the hypotenuse. So therefore, to get the short side, I need to cut the hypotenuse in half. I need to divide it by 2. And then to get the long leg is just the short leg times the square root of 3. So this piece right here is 3/2 times the square root of 3. But notice that's from here to here, and from here to here is the same, so I need 2 of these. So I need 2 times 3/2 times the square root of 3. Oh, look at that. The 2's cancel out, and I'm left with 3 square root of 3. So the distance from A to B is equal to 3 times the square root of 3. So notice how many things I brought into play here. I used what I know about radians to help me find the area, and I used what I knew about degrees and right triangles and special right triangles to find missing side lengths. So sometimes you got to pull it all together. Use what you know about everything and apply it all to the same problem. Okay, so good luck with that.